In part A, we're asked to verify that minus 5 plus I is a solution to fz equals 0. So we're just going to start with working out what is f of minus 5 plus I. We're going to basically put that into f of z. And we explicitly show minus 5 plus I substituted into f of z in place of z. When we've done that, you work it through really clearly, explicitly, what each of these brackets expands out to, what it simplifies to, and you verify that that then gives us 0. We've verified it, we've shown it. We haven't started with the assumption that it's true. We've put it in, we've worked it through, and we've shown it's equal to 0. Now, hence, we are using the fact that minus 5i is a solution. Okay. We've just shown that minus 5 plus I is one solution. We can deduce from that that another solution is minus 5 minus I, because solutions appear as conjugate pairs. Based on this information, there are two different ways to show part B. Okay, we could use alpha plus beta is minus 10 and alpha beta is 5 squared plus 1 squared is 26, and then that these solutions come from a quadratic of z squared minus alpha plus beta z, so that would be plus 10z plus alpha beta. Alternatively, and perhaps more directly from here, using the factor theorem, so that leads us to z minus that first solution must be a factor, and also z minus its complex conjugate is also a factor. So if the first bracket is a factor and the second bracket is a factor, when I multiply these together, I've also got another factor. So now it reduces to showing that this multiplies out to the quadratic given. Neat trick for doing that, z plus 5, so just regrouping those parts. Then when I multiply this out, I get z plus 5 all squared plus z pi plus the bracket times I, and then minus the bracket times I, which cancels out, and then I get a minus I squared, and then that will get me to the result I've been asked for. On part C, with the hence, we're given so start fz equals your cubic. We're told our quadratic is a factor, so at this point we can factorize that by inspection. Okay, and minus 2, not quite, z minus 4, and then we can solve it completely, because that is f of z, and we want to solve fz equals 0, so that equals 0 when either of those brackets is 0. So I'll get my solution from there, or I get my solution from that quadratic, which from parts A and B were those.